Well, it does not really matter whether you are going in an interview for a high-end Java developer position or as a fresher. The interviewer always starts asking questions from basic Java itself. When I say list 5 features of Java, it may seem quite easy to you. And you start with naming the features as portable, robust, secure, high performance, etc. But if I say, how is Java secure? Are other languages not? Or if I ask you to explain each and every point in detail, you might get stuck after a level of explanation. Well, don't worry, that is what I am here for. Let's start with the features of Java and dig in deep to each one. The first feature of Java is simple and clean. And the reason for it being simple is, it has look and feel familiar to C, C++, and Objective-C, so that a programmer could learn it quickly and can easily migrate to Java. Java is clean because it removed many confusing and complex features that were previously supported by other popular languages. The first amongst them is GoTo statement. While GoTo gives power to programmers for changing the normal flow of execution of a program, by jumping unconditionally to a label. If not handled carefully, GoTo can decrease the readability of a program, and increase its complexity and maintenance. The second famous feature from old languages, removed by Java was pointers. A pointer is a variable whose value is the address of another variable. That is, a pointer provides direct address of the memory location. While it was a very powerful feature, it was insecure, and has a lot of limitations, such as it reduces the execution time of the program, storage space, and increased complexity. Moreover, if pointers are updated with incorrect values, it might lead to memory corruption, and pointer bugs are too difficult to debug. The next feature in the line, removed by Java, was overloaded operators. Now, the interviewer's next question might be, then how do you use plus operator while printing the value of a variable? One important point to note here is Java doesn't support user-defined operator overloading. However, there are some custom operators, overloaded. But, you can't define your own operators to act in the same way though. The reason is, 1. To avoid programming errors. If you allow programmers to do operator overloading, they will come up with multiple meanings for same operator, which will make the learning of any developer hard, confusing, and messy. 2. Operator overloading is more difficult, and if the same thing can be achieved by using methods in more intuitive and clean way, it does not make sense to use operator overloading. The next feature not supported by Java is multiple inheritance. When an object acquires properties from more than one object at the same time, it's called multiple inheritance. Let's suppose we have a class, hi, which has a method named print which prints hi text on the console, and another class, hello, which have the same name method print but it prints hello on the console. That is, we have methods in two different classes who have same names but different implementations. If suppose Java had allowed multiple inheritance, and we had a class called printTest, which extends class hi as well as hello, and the object of this class if tries to access print method, there would be an ambiguity that whose print method it calls. Should it print hi? Or should it print hello? Java removed multiple inheritance to remove such ambiguity. The next in the line, removed by Java, is destructors. In old languages, programmers were responsible for destruction of useless objects, and because of its negligence, out-of-memory error was very common. Java, on the other hand, introduced an assistant called garbage collector, which always run in the background, and free up the memory taken by any useless objects. Feature number 2. Support OOPS. And as you say, support, the question lined up can be, why do you say support? Isn't it pure OOPS? The answer is, no. In a pure object-oriented programming language, everything accessible is an object. Java has primitive data types, and also does not support some important feature of OOPS, such as multiple inheritance. Thus is support OOPS but is not pure object-oriented programming language. Feature number 3. Platform independent. A language is platform independent if it can be run on any platform, that is operating system, without any modification. Java is a two-stage system. At first, Java's compiler changed the source code into .class file, also known as bytecode. These bytecodes run on JVM, that is Java Virtual Machine, regardless of the operating system. And this feature makes it platform independent. Later, Java's interpreter changed the bytecode to OS-specific machine language. Feature number 4. Portable or architecture neutral. Java is portable because of, number 1, the bytecode, and number 2, the size of primitive data types are machine independent. Its data types acquire same bytes of memory, for both 32 and 64-bit operating system. Feature number 5. Robust. Java is robust because it ensures the reliability of code before execution through strong memory management by removal of pointers and introduction of garbage collector, compile time and runtime checking mechanism, and exception handling. Feature number 6. Free and open source. First of all, let's understand the meaning of open source. Many people tend to think that free software are open source. But that's incorrect. A software is open source if its source code is given for free download, publicly and officially. The best example is NetBeans IDE, which is free, but not open source, since its source code is not available publicly. On the other hand, we have Eclipse IDE, which is open source because its source code is available for anyone to download, copy, redistribute, which is usually part of the general public license. Feature number 7. Secure. The reason of Java being secure is, point 1, stack corruption and buffer overflow is impossible, and because Java do not have pointers, you also can't access out-of-bounds array, and other error-prone codes. Point 2. Java helps us in writing safe code by checking type safety, automatic memory management, garbage collection, and range checking on string and arrays. The biggest reason for Java being secure is its sandbox model. As we all know, Java is designed as a language for creating applications on network, in the form of applets. Thus, Java exposed a significant amount of risk to its users. Java designers were well aware of the situation, and hence they developed Sandbox model, which consists of 3 parts: the bytecode verifier, the applet class loader, and the security manager. Bytecode verifier makes sure that format of the bytecode fragment is correct, and trustable to run. The applet class loader adds security, by separating the package for the classes of the local file system, from those that are imported from network resources. And the security manager determines what resources a class can access, such as reading and writing to the local disk. Feature number 8. Distributed. Java is called a distributed programming language because it allows multiple programmers, at different locations, to collaborate and work on a single project through RMI and Corba mechanisms. Feature number 9. Multi-threaded. Multi-threading means handling multiple tasks simultaneously. The best examples are games such as car racing, etc., and Microsoft Word, which has spell check running in the background while you are still writing in it. Feature number 10. Dynamic and extensible. Java is called dynamic because of its capability of dynamically linking new classes, methods, etc. It also supports functions written in other languages, popularly known as native method support. Let me know if you have anything to add in this video. Thanks for watching.